Welcome to the 10th session on ionic equilibria. In this again it is a continuation of hydrolysis of salts, but that will be of a different salt. So, let us go into the topic. Here I am going to consider the hydrolysis of salt formed from weak acid and a weak base. So, acid should be weak as well as base should be weak. So, for example, I will take a weak acid CH3COH combines with a weak base like ammonium hydroxide, and this will form a salt that will be CH3COONH4 plus water. So, this is how you are going to get a weak acid and a base neutralized to give a salt. So, one of the example is ammonium acetate. Now, let us see what happens in this case. Here I have CH3, this is the salt, okay. That was the acid and the base which neutralized each other to form the salt. So, we have a salt CH3COONH4, and this salt, as you all know, can combine with water to give CH3COOH, which is a weak acid, and ammonium hydroxide. Okay. Now, you can just watch that you are having acetic acid as well as ammonium hydroxide. This acetic acid and ammonium hydroxide, in this case acetic acid is a weak acid, ammonium hydroxide is also a weak base. Okay. Now, in this case this acetic acid and ammonium hydroxide, they can again get hydrolyzed as CH3COH plus water, giving CH3COO minus plus H3O plus, and ammonium hydroxide can ionize and give ammonium ions as well as OH minus ions, but these dissociations, they are very weak dissociations. So, only a very little acetic acid and ammonium hydroxide may get ionized. Okay. Now, what happens is here we have H3O plus and OH minus ions, these two can combine together and get converted into neutral water. So, what happens is mostly in these cases the solution will be neutral, and there might be slight changes, it can be very slightly acidic or very slightly basic, depending on how far the acid gets dissociated and base gets dissociated. If acid is getting dissociated to slightly greater extent, the solution may become slightly acidic. If base is getting dissociated to a slighter greater extent, the solution may be basic, but very little, that is very feeble basic solution. Okay. And most probably the pH will be around 7 itself. Now, let us go for the expression of hydrolysis constant. Here I am going to take the salt which will be completely ionized, B plus and A minus, which interacts with water to regenerate acid and base. This is a weak acid and this is a weak base. In previous sessions we have checked for the dissociation constant of either the weak acid or the weak base as the case appears. So, here this is the case for hydrolysis constant. I am going to consider water to be present in excess, and therefore, the expression for hydrolysis constant K H is equal to concentration of H A into concentration of BOH. They will not be ionized, and you do not have any of the ions getting cancelled over here, because on this side there is no ionization. So, we have both the ions, the B plus and A minus in the denominator. Now, since both acid and base are weak, we have to consider the ionization of the weak acid HA plus water giving H3O plus A minus. Okay. And from this again water is considered to be in excess. Ka will be equal to concentration of H3O plus into concentration of A minus whole divided by concentration of Ha. Okay. Now, since base is also weak, we have to consider the dissociation of the base too. So, take BOH, which gets dissociated as B plus OH minus. Now, again here Kb is equal to concentration of B plus into concentration of OH minus whole divided by concentration of BOH. Now, to arrive at the expression, here both acid and base are weak, and we have found out the dissociation constant of both acid and base. Now, what I am going to do is I am going to divide these two dissociation constants on ionic product of water, that is Kw divided by Ka into Kb, because in former cases when acid was weak we took it as Kw by Ka, when base was weak we took it as Kw by Kb. Now, in this case both are weak. So, let us see whether we can arrive at the expression of hydrolysis constant. Kw is represented as H3O plus into concentration of OH minus. So, Kw I put it as H3O plus into concentration of OH minus divided by Ka, this is Ka. So, I have H3O plus A minus, which is in the numerator, Ha which is in the denominator goes to the numerator because that is a division, Ha. Now, again you should take Kb where we have B plus into concentration of OH minus, and in the denominator we have BOH that goes to the numerator. Now, let us cancel the terms. Here we have H3O, H3O plus, OH minus, OH minus, and the final expression will be concentration of Ha into concentration of BOH divided by concentration of A minus into concentration of B plus. Now, compare this with the previous expression for Kh. Both are same. Okay. So, what does it mean? Kh is equal to Kw by Ka into Kb. So, this is the expression for hydrolysis constant for a salt where both acid and base is weak. Okay. Now, we have to derive an expression for degree of hydrolysis. Again, this expression comes from the first one we have written here, that is B plus plus A minus plus H2O gives HA plus BOH. The same expression is written here. Initial concentration, again we assume that Ba is the salt which is written in the form of ions, and therefore, both will be having the same concentration as C moles per liter. An initial state you do not have the concentration of HA and BOH, so they will be 0 at equilibrium when X is taken as the degree of hydrolysis. We have concentration of B plus as C into 1 minus X. Similarly, A minus will also be C into 1 minus X, HA will be Cx and BOH will be again Cx. Now, let us write the expression for hydrolysis constant from using the above equation. That will be concentration of HA into concentration of BOH, again considering water to be present in excess. In the denominator, you will have only concentration of B plus into concentration of A minus. Now, let us substitute these values with the concentrations which we have assumed to be. HA is Cx, BOH is also Cx whole divided by B plus is C into 1 minus X and A minus is also C into 1 minus X. Now, cancelling the terms which are present in the numerator and denominator. See, C and C gets cancelled, the C and the C gets cancelled, and finally, the expression takes the form x square, x into x, x square, 1 minus x into 1 minus x, it becomes 1 minus x whole square. So, now I can put the expression for hydrolysis constant K H C equal to x square divided by 1 minus x whole square. This is without any approximation. Now, we are going for an approximation. What we are going to do is, as we have done earlier, x is considered to be very low value than 1, and therefore, you can put x minus 1 approximately equal to 1. So, the denominator term becomes 1 and I can put the hydrolysis constant K is equal to x square, okay, and therefore, degree of hydrolysis x will be equal to square root of K H. Again, I am going to substitute for K H, we have derived it here, that is K H is equal to K W divided by K A into K B. So, I am going for that, which is equal to square root of K W into K A to K B. So, K W divided by K A into K B. This is the degree of hydrolysis, the expression here. It does not involve the concentration term, and therefore, hydrolysis of a salt formed from weak acid and a weak base is independent of the concentration, point to be noted. Okay. In the other two cases, concentration determines the degree of hydrolysis. Okay. Now, we are going for the expression for pH. Since if you want to find out the pH, let us consider the weak acid to be dissociated. HA is a weak acid, dissociates to H3O plus and A minus, because only from that we will be getting an expression for H3O plus. So, again assuming water to be present in excess, I can write an expression for Ka is equal to concentration of H3O plus into concentration of A minus divided by concentration of HA. Okay. Now, we are going to find out an expression for pH, and therefore, what I am going to do is, I am going to take it in terms of H3O plus, that is concentration of H3O plus is equal to, this is, keep it here, the other two terms are taken to the other side. So, I have Ka, Ha which is in the denominator, when it goes to the other side, that is to the left hand side, it becomes numerator Ha divided by concentration of A minus. Now, let us recall, I have written it here, that is the concentrations of all these terms. Ha, that is the concentration of Cx, A minus, the concentration is C into 1 minus x, that is again from the previous expression. So, I am keeping it as H3O plus is equal to Ka into concentration of Ha is Cx divided by concentration of A minus is C into 1 minus x. C and C gets cancelled. So, the expression can be written as Ka into x by 1 minus x. Now, let us recall the expression for hydrolysis constant without any approximation. It was x square divided by 1 minus x whole square. Okay. Now, comparing these two, here we are having x divided by 1 minus x, and in this case it is x square by 1 minus x whole square. Now, this can be therefore taken as root of Kh. So, I can put it as Ka into root of Kh, again substituting for Kh, Ka into root of Kw divided by Ka into Kb. This was an expression for Kh when both acid and the base were weak. Here this Ka gets cancelled as root Ka, and finally, I can put this expression as H3O plus is equal to root of Kw. This Ka goes into the root, so that becomes Ka whole divided by Kb. Now, taking negative logarithm, this becomes pH is equal to negative logarithm, here it will be in the numerator minus of log Kw, and that is within the root. So, half, then minus of half log Ka, then minus of minus, it becomes plus, or I can put it as minus of minus log Kb. Substituting, this becomes minus half log Kw, and Kw I can change it as pKw. pKw. So, the minus sign is gone, it becomes positive. Now, again here minus log Ka is taken out. So, I have plus half pKa. Here again this is taken as, one more point, this is half log, it becomes minus half log, no, I remove the log 2, let that be pKb. Okay. So, the final equation I will write it at the top here. I can put it as pH is equal to pKw is equal to 14 and half of pKw will be 7 plus half log is taken as pKa. So, half of pKa minus pKb. Now, here we have to note that the pH of the solution depends upon the dissociation constant of pKa and dissociation constant of pKb. See, whichever is greater, depending on that we will be getting it as the pH of that solution. If they both are same, the pH will remain around 7, which will be neutral. This was what which we have been discussing in the session when hydrolysis takes place. This pH of that solution will be around the neutral value. So, this is an expression for pH for a salt from weak acid and a weak base. Next, we will go for a problem. Here the problem goes on like this. There is a hydrolysis constant of ammonium acetate. Whenever you get a salt, you should first identify whether it is a salt of weak acid and a weak base, or strong acid and a weak base, or weak acid and a strong base. Ammonium acetate means it is a salt formed from ammonium hydroxide, which is a weak base, and acetic acid, which is again a weak acid. So, both are weak, and its degree of hydrolysis in 0.1 molar solution at 298 Kelvin. So, you have to find out the hydrolysis constant of ammonium acetate and its degree of hydrolysis. So, these are the things we have to find out. We have to find out the hydrolysis constant, then we have to find out the degree of hydrolysis X and also the Kb for the base. No, Kb is given here, not Kb. Kb of the base is given and Ka is given, and you have to find out the pH also. So, these are the three factors which we have to find: the hydrolysis constant of ammonium acetate and its degree of hydrolysis in concentration is equal to 0.1 molar, then Kb is given 1.8 into 10 to the power 5 minus 5, Kw is given 1 into 10 to the power minus 14, and Ka for acetic acid is given as 1.75 into 10 to the power minus 5. So, since they have given all these values, Kw is given, Ka and Kb is given. So, you can find out the hydrolysis constant Kh is equal to, the expression goes like Kw divided by Ka into Kb. So, you can identify this expression only if you identify the salt is from both weak acid and weak base. Now, the values are substituted. Kw is equal to 1 into 10 to the power minus 14 divided by Ka is equal to 1.75 into 10 to the power minus 5, again Kb, that is 1.8 into 10 to the power minus 5. Now, using a calculator, scientific calculator, you can calculate it, and the answer was found to be 3.175 into 10 to the power minus 5. This is the hydrolysis constant. Now, since we have got the hydrolysis constant, we can easily find out the value of X. Degree of hydrolysis is equal to root of hydrolysis constant. Hydrolysis constant you have already found out. So, just substitute the value 3.175 into 10 to the power minus 5, and the value comes as 5.6347 into 10 to the power minus 3. Okay. Next is we have to find out the pH. For pH we have got the expression. Remember the pH for a weak acid and a weak base salt, pH is equal to 7 minus half into pKa, sorry, here it is plus pKa minus pKb. Yes, pKa minus pKb. So, that is the expression we have derived, and putting 7 plus half. Here there is one difference, they have not given the value of pKa. So, I have to put it as minus of log Ka. Again here minus of log minus log Kb. Okay. And substitute the values 7 plus half. This is a point to be noted, because pKa values are not given, we will have to take it as negative logarithm of Ka and negative logarithm of Kb. Those values are given here, and that is equal to minus of 1.75 into 10 to the power minus 5, minus and minus, that becomes plus 1.8 into 10 to the power minus 5, and these should be the logs. There is no space to write. Here I can put it as this negative log, and here it becomes plus log. Just solve for it and you will get the answer as 7.0074. So, you have to be careful, instead of pKa do not use the values of Ka, instead take it as negative logarithm of Ka, otherwise the answer will go wrong. Now, let us conclude, that is, here hydrolysis of a salt of a weak acid and a weak base is being considered, in which we have been determining the hydrolysis constant Kh is equal to Kw by Ka into Kb, and degree of hydrolysis is equal to x, which is equal to square root of Kw by Ka into Kb. Here also you do not have any C involved. Now, again pH is equal to, this is a minus sign not plus, pH is equal to 7 plus half into pKa minus pKb. Thank you.